Hello all, welcome to the second session on the functions. In the first session, we talked about the different relationships between x and y and how any relationship could qualify to be a function or not. Let's take it forward to now understand what are the different types of functions, what are the different shapes of functions, and how can we plot any function on an xy graph, right? Before we get started, we got to understand something called as a degree of the function, right? So degree of the function. Degree is nothing but the highest power of x. And we will see what it means, right? So every function will have some power of x, and the highest power of x is called as the degree of the function, and that is something which determines the type of the function and the shape of the function. So let's take an example. Let's say that we have a function y is equal to 2x plus 5, correct? Now what is the power of x here? It's basically 1. 2x to the power of 1 is x. So basically the power here is 1, right? So when the highest power of x is 1, it means that the degree of the function is 1, because degree is nothing but the highest power of x. So the point I'm trying to make is that when the degree of a function is 1, it is called as a linear function. Okay? It's called as a linear function. And the shape of the function would be a straight line. Okay? Now the straight line could be going like this, or like this, or a horizontal line, and so on and so forth. So the shape of the straight line can vary, but it will be a straight line. So basically what I'm saying is that when the degree of the function is 1, basically the highest power of the function is 1, it is called as a linear function, and when we will plot it, it will turn out to be a straight line. Okay, and we will see how to plot any function, right? Similarly, if the highest power of x is 2, let's say y is equal to 3x square plus 4x plus 7. Let's say I'm just making it up. The highest power of x is 2 here, because the power of this term is 1. The power of x here is 2. So this becomes the highest power. When the highest power of x is 2, it means that the degree of the function is 2. And for a 2-degree function, it is called as a quadratic function. It's just a name. It's called as a quadratic function. And we will talk about all of these things in detail in separate sessions. And the shape of a quadratic function would be like a parabola or a necklace shape. Now again, it could be opening upwards, it could be opening downwards, it could be opening in any other way, but the shape will be of the necklace form. Okay. Similarly, you could have a function wherein the degree is 3. Let's say 4x cubed plus 2x plus 5, right? The power of x here in this term is 3. The power of x here in this term is 1. There is no x term here. So overall the highest power of x is 3, and hence it becomes a cubic function, right? And it will have its own shape. For the purpose of these sessions, we will confine ourselves to the linear functions and quadratic functions. But the point I'm trying to make is that every function will have a degree. That degree will be nothing but the highest power of x, and that will determine the type of the function and the shape of the function, right? Now, let's talk about how do we plot any function on an xy graph. He asks us, okay, you have a graph 2x cube plus 7x plus 5. Somebody says, plot this function on a graph. We all know that it's a cubic function because we just saw, right? The highest power is 3, so it's a cubic function, the degree is 3. But how do we plot it? To plot any function, all we need is some x and y points, correct? So basically, we just create a table, right? X and y. We give some values of x and we find the corresponding values of y. For example, in this case, when we put x equal to 0, we get y equal to 5. When we put x equal to 1, we get y equal to 14. When we put x equal to minus 1, we get y equal to minus 4. And so on and so forth, right? So basically, the point I'm trying to make is that whenever you get a function, all you got to do is to create a small table of x and y points and have those points. After that, we can just plot these points and join them. That becomes the graph of the function. In this case, probably we may need some more points, but just to give you an idea, 0, 5 is this, 1, 14 is this point, minus 1, minus 4 is, let's say, this point, and so on and so forth. So basically, at the end of the day, you will have a bunch of points which you can join to plot the graph, right? So this is how you can plot any graph in the world. You don't really even need to know what the shape of the graph will look like. Even though, as I said in the beginning, that for the purpose of these sessions, we will confine ourselves to the linear functions, right, which are straight line, and quadratic functions, which will be in the shape of parabola. Okay, maybe we can take an example to plot any linear function this time. Function fx is equal to 2x plus 4, right? And we got to plot that. Again, as we did last time, all we got to do is to create a simple table, x and y, and get some points, plot those points on the xy graph and join them, right? So let's start, let's say, with 0. When x is 0, the function's value, or basically the y value, will be 4, right? 2 times 0 is 0 plus 4 is 4. When x is 1, this will give you 6. When x is 2, this will give you 8. Maybe we can take a negative value of x. When x is minus 1, it will give you 2. So essentially, we got some points like 0, 4, 1, 6, 2, 8, minus 1, 2. These are some of the points on this graph. All we got to do is to plot those points here. So this is 0, 4, 1, 6, let's say, is somewhere here, 2, 8 is somewhere here, minus 1, 2 is somewhere here. So we got 3 or 4 points and we join them. And as I mentioned last time, any linear function will always be in the shape of a straight line. Okay, we'll talk more about the linear functions and the different permutations and combinations and the different types of linear functions, which could be, like as I was saying, the straight line could be going like this, or horizontal or vertical. We'll talk about all of that in our next session. Hopefully you guys liked the video and it gave you a perspective as to what are the different types of functions, what are the different shapes of functions, what is essentially a linear function, what is essentially a quadratic function, what is the degree of the function which actually determines the shapes and the type of function. Sounds good. Hope you liked it. Please do like and subscribe to the channel, and we will see you in the next session. Thank you.